the slide in slideshow. Yeah.
Okay. Yep. Okay. Can I start?
Sure. You can start now.
Okay. Thank you. Thank you very much for your wonderful introduction. So for me, and this year is 2020. It's a quite special year, but that is not only for the COVID-19, but also our university, Nagoya University, School of Engineering in the Nagoya University and the University Technical Malaysia Malacca. So both department has a good strong relationship. So that was started from this year. So by the MOU. So and also in this MERT 20. So we are so happy to helping and doing some work. So to have this wonderful symposium. So especially for the Professor Fazuli, and you have done so very good work. So I've explained about the in situ observation of friction surface with reflectance spectroscopy. This is the new investigation method. Do you know diagnostic for the tribology by using the reflectance spectroscopy? So at first, I want to explain about what is the in situ method for tribology research. That is also important because the surface, during the friction, surface could be changed, changed and changed, after repeated sliding. Not only the surface roughness, but also the material on the topmost layer, during the repeated sliding. So we should do the in situ observation to know to clarify the friction and wear mechanism perfectly. And the second, what is the advantage of reflectance spectroscopy? So we introduced this reflectance spectroscopy to do the investigation of the surface, contact surface and sliding surface in the tribology. And third, I would like to explain about the application of this in situ observation with reflectance spectroscopy to clarify the ultra-low friction mechanism of carbon nitride coating, to explain of each parameter, thickness, hardness, and surface roughness. So finally, we found the ultra-low friction of carbon nitride coating in dry nitrogen blowing. It's caused by the solid lubrication with thin graphitic layer. So our new method in situ observation can give such kind of the good advantages. So what is the in situ method for tribology research? So of course, experimental research for tribology has a long history. In up to 1950, the measurement of friction of surface damage, damage in simple bench test, that was happened. And so after 1950, the tools of surface analysis started to become available as SEM, EDS, XRD, XPS, AES, FTIR, Raman spectroscopy. So there are so many kind of the surface analysis method as started. But by using this surface analysis method, that is just after the friction. So after the wear. So it means such surface was analysis. But from 1990, in situ observation method for rubbing contact with the tool of surface analysis. So that is also important. So the in situ method for friction interface, that was started from the Imperial College of the London, 1967. So they have used such kind of the interference, fringe, through the some light, through such glass discs. There is a steel ball. There is a contact surface. If they can use the monochromic light, they can observe interference fringe, and also they can estimate the film thickness. So this paper has just get the such kind of the film thickness distribution. I think that is so good in the field of the elastohydrodynamic contact. So they have doing some mapping of elastohydrodynamic contacts. That is very, very epoch make good research work. And after their work, so Professor Hugh Spikes in the Imperial College, London, so he has done in situ study of metal orylite friction modifier additives. So their method is quite close to the Professor Cameron's research work. There is a glass discs and the steel ball is here. Lubricant is here. So there is a microscope. So Professor Spikes has also detected the thickness of the liquid film like that. Even if such lubricant film thickness is less than 100 nanometer, even if such a nanometer scale thickness, oil film, it can be detected. So by such kind of the thing, and also, he has got the rolling speed dependency, like that. So but by their method, they have just measure the thickness of oil film, and but this method is so nice, so it's commercialized and we can buy such kind of the method. And in the next stage, in situ Raman tribometer, that was developed by the United States U.S. Naval Research Laboratory. So John Wall was a singer. So both has developed such kind of the in situ Raman tribometer. So for this one, they did measure, not measure, they did detected the new tribe new material on the contact surface by using the Raman spectroscopy. So there is a repeated repeated sliding machine. There is a hemispheric counterface. It's a transparent glass material and a microscope objection. And there is a lever and normal force can be applied by like this. And there is a sample. And on this method, by using the Raman spectroscopy, it means they got the material property of tribal films as a solid lubricant. So it means they would like to get the effect of the material on friction and wear. So they have used the boric acid and annealed boron carbide coating. So for this one. So on the basis of their research work, Naval Research Laboratories, after the repeated sliding, the carbon content is increasing in the tribal film, but the boric acid is decreasing like that. And the friction coefficient is also decreasing with the increasing of the carbon. So by using such kind of the equation, the volumeric percentage of boric acid and the carbon, they estimated the friction coefficient is like that. So it's a measured friction coefficient and calculated friction coefficient from this equation. So both friction coefficient is quite matched. See, it's like this. So they have just detected the material of the tribal film. And also by using the Raman spectroscopy, they got the G band, D band, and also graphite graphitization of the diamond-like carbon by using like this. So it means that up to the 1967, only thickness of oil film. And after the 2008, structure and the element of tribal film, both were detected by the in situ. But no good method to investigate the thickness and property both in situ. Because for the controlling of the friction and wear, the thickness and the properties of the tribal films are so important. So it means we should measure the thickness and the properties of the tribal film. So in situ, friction. Also, we should measure the friction coefficient. So we have So we introduced the reflectance spectroscopy. Is this one? This is, of course, reflectance spectroscopy. It's quite so similar. So with the interference method, but by checking the spectrum of the reflectant light like this, wavelengths and reflectance, so we can detect not only the thickness of the film, but also the material also. So because by using the because for this reflectance is including the optical properties of the topmost layer. So it means if there is a new coating material is like that, so reflectance spectrum has some information. So not only the topmost layer, but also the substrate. So like this one. So by using the reflectance spectroscopy, of course, interference could be happened. So that's why from the spectrum, we can get the thickness of this film is like that from delta lambda. But also, we can detect the reflectative index and also the extinction index K. So both value. So and also we can get the dielectric constant from this N and K value. So it means by using the reflectance spectroscopy, we can get the optical property of the topmost layer and the surface. So and such kind of the optical property as N and K. So we can estimate the material from the N and K. So how to estimate the thickness of the coating? So at first, we should estimate the NKT value of topmost layer. And we can make some optical model is like this. So total reflectance can be described like this. So R value can be described like this. N is small n minus ik. So n is reflectative index and k is the k is the other extinction coefficient is like this, and beta is coming here. So finally, we should do some matching of the spectrum of the optical model. So and that was just one layer. So how about the two more layer? So we can make one more layer is like this. So it means in the principle, we can make such kind of the optical model for the multi-optical layer. So N and K value, reflectative index N and extinction index K, what we can estimate as a material property. So this is one example for the carbon material. So in the case of the carbon material, from the diamond to the graphite, diamond structure is a CCSP3 structure, and the graphite structure is a CCSP2. So, and in the case of the diamond, extinction index K value is almost zero, quite transparent. But graphite, this value is quite large, so it's very blacky, is graphite. So this is the extinction index, is coming from the transparency. And the reflectative index is diamond is about 2.5. The graphite is slightly large. So amorphous material is coming between these ranges is like that. So it means if we can get the reflectative index N and the extinction index K of the layer, so we can estimate the structure. So and also the NK value can give the good property of the material strength. So this right figure is showing the effect of the reflectative index on the indentation hardness. So from this curve, we can estimate the hardness from the reflectative index is like that. And this is this curve. So this reference so curve was so developed by the Professor Robertson. So he got such kind of the very, very useful equation. Hardness, so to the two-thirds, is so the proportional to the sp3 fraction. So it's mean like that. So it means if we can know the nk value, and after that, if we know the sp3 fraction, we can estimate the hardness from this one. And also in the case of the carbon nitride coating, if carbon nitride coating is including so many type of the bonding, CCSP3, CCSP2, and CN. So each bonding has each specific spectrum. So it means if we can do the matching, so we can get the fraction, volumeric fraction of sp3 bonding, sp2 bonding, and nitrogen bonding. So yeah, by the matching is like that. And also by using the, so if we know the N and K value, surface roughness also can be estimated from optical constant. Surface roughness is like that. So if we can so estimate the surface roughness layer, so surface roughness layer is not so dense so layer. Maybe more than the half is the air, and the solid is like this. So it means on the base of such kind of the volume fraction of the carbon nitride and the so against the air, so we can get the surface roughness layer is like that. So it means so from the NK value, so we can estimate also the so RQ surface roughness. So it means so in reflectance spectroscopy that can give so many so interesting so property. So not only the thickness, so but also the NK value, so optical properties. So it means the in situ observation of the interface between carbon nitride and sapphire to explain the role of each parameter as TH and root mean square roughness. T is the thickness and H is the hardness and the roughness with reflectance spectroscopy. If the TH and roughness so can control the friction and wear of the carbon nitride coating, if we can measure the TH and roughness, so in the in situ, so by using reflectance spectroscopy, maybe we can estimate the friction. So we make such kind of the friction tester. So there is a sapphire glass, so we can get the reflectance spectroscopy. So through this sapphire glass is like this. So during this test, so we have also measured the friction coefficient. So this figure is showing the variation of the friction coefficient. Initially 0.1 to 1.5, but after repeated sliding, it leads to the less than 0.01. Very, very low friction is like that. During this process, so we have measure the thickness of transformation layer. So 10 nanometer was such nanometer scale. So this thickness is increasing gradually. So it means that the friction coefficient is depend on the thickness. How about the roughness? So roughness change has also detected inside you. Also roughness is increasing. So, and how about the hardness of the topmost layer? Hardness of the topmost layer was detected by this method, so like this. But on the basis of the such kind of the results, so by using the Holling's method, Holling has developed the friction model. So by using the solid lubrication, solid field lubrication. So by using this Holling method, so we have to detect the hardness of the soft film and the roughness of the topmost layer. So that is also, and the thickness of the coating. By using this method, finally, so this red point is calculated value, and the black line is a measured value. So we can estimate the friction coefficient so well. So that's why, so even if the friction coefficient has changed by the repeated sliding, we can estimate the friction coefficient by detecting the thickness, roughness, hardness of the topmost layer. So now, so I'm finishing so about my talk. Anyway, so this in situ method of the with the reflectance spectroscopy, that's quite useful. So to understand the friction mechanism. So thank you very much for your attendance. For your care. Thank you.
Professor Umehara, on behalf of everyone here, I would like to thank you for a most interesting presentation. Now, we will move to the question and answer session.
Okay, thank you.
Can I have some question here?
Okay, Amrik, can I ask the question? Okay, Prof. Umehara, okay,
Yes.
thanks for the nice presentations. Okay, actually, I have one question on your slide number 16, 1.6. The graph of the hardness versus reflectance. If I'm okay, this one. Okay,
is it all right?
Next one.
This one?
Next.
Next. Okay.
16, 1.6. Okay, this one.
This one?
Okay, this one. Okay, the indentation hardness versus the refract index.
Yeah.
Okay, is it that correlation can be used as a generic equation for the diamond like carbon coating or other materials?
I think this is only the diamond like carbon. Also, especially for the non-hydrogen material. So it means this relationship is not the standard one. It's just empirical. So it may be kind of the experimental tendency, the relationship between the hardness and this one.
Okay. What do you mean by the sample 1, sample 2, sample 3, and sample 4? Sorry.
So it means that is dependent on the coating method.
Okay.
And I think maybe the reflective index, it depends on the density of the material. If the high dense material shows a high reflective index. So and in the case of the carbon material, maybe high dense is gives a maybe high hardness. So but of course normal hardness of the metal, it depends on some defects and the dislocation of the something. But in the case of such carbon and pure material, maybe the hardness is depend on the density. So that's why I think hardness has good relationship to the reflective index, maybe.
Okay. Yeah. So you mean that this relationship is only valid for the carbon coating, especially for the hard coating, right? Not for other material. Okay, thank you very much.
Yeah. But now, okay.
Do you like to continue, Prof. Umehara?
No, it's all right.
Okay. Can I have another question from the participants? Okay, since there are no questions, I think in slide number 14, in estimating the thickness of coating, I think it was mentioned that the fitting error is minimized, if I understood correctly.
This one?
No, I think next. Is it next? Next slide.
Next.
Yeah. This one.
Okay.
The previous. Was it the previous one? Okay. Yeah, this one.
Okay.
Yeah. Okay. So I see that the fitting error is minimized in estimating the thickness of coating. Is there any specific optimization method used here?
That is very, very good question. Yeah, because in the spectrum, so it means the data is too much. So but the unknown parameter is not so many. So it means if we will solve this question, the solution could be so many. So not only one so one component. So, but also so many sometimes. So it means that is very, very so important question. Now we are trying to get now, so we should get the only one so combination of the NKT value. But if we will solve this question, so sometimes so we can find so many so solution. So the combination NK so T value, NKD value. So yeah, that is also an important question. So it means at first we will so check the so tendency of the effect of the n value, k value, d value. So like if the n increasing of the n, so the solution will be stabilized or not. It's like that. So yeah, that is also important. Yeah.
Thank you, Professor Umehara. Can we have a quick question, a last question, before we move to the next speaker? Any questions from the participants? Yeah, it seems no question here. Yeah? So I think we can move to the next session. Okay, again, thank you very much, Professor Umehara, for your sharing.
Yeah, thank you very much. So
just give about 2 minutes before we start the next session. We'll start exactly at 12:30 in the afternoon. Okay, now let's move to the next speaker. It is my pleasure to introduce our next speaker for today, engineer technologist Dr. Khairil Anwar Abu Qasim from Malaysian Institute of Road Safety Research, in short MIROS, who will be talking about future of safer vehicles in ASEAN. He is currently the Director General of MIROS and also the Secretary General of ASEAN NCAP. He received a PhD degree in Business Administration from UCSI University Malaysia in 2017. His research interests include automotive homologation and crash testing, automotive consumer behavior, and vehicle safety assist. Let's welcome Dr. Khairil.
Okay, thank you, Dr. Amrik. And thank you everyone for giving me this opportunity to present about safer vehicles. And of course, in our region, if you mean safer vehicle, is ASEAN NCAPs is the most referred for the region safer vehicles. So I changed a little bit on my topic today, which is the updates on ASEAN NCAP for 2020. I think we have 15 days more to to graduate from 2020 and the future plan. Thank you for introduction just now. Let me just a little bit re-emphasize on what I'm doing now. I'm the Director General of Malaysian Institute of Road Safety Research as a government officer, as a research officer also in MIROS, and I am the Secretary General for NCAPT. I'm one of the professor adjunct in UTM, advisor for Society of Automotive Engineers Malaysia. I'm sure most of you already know what is NCAPS all about, new car assessment program. We are testing new car and give you ratings, and this is NCAPS. Of course, this might attract a question why we need so much NCAP. I leave it to you to understand my presentation first, then I will answer you if you want to ask about it. No problem. And we do also have safer cars for India. This has not been to a level of NCAP because the procedure is a little bit different, where it's not managed by the locals. It's managed by Global NCAP, which purchased the vehicle and tested in Germany, and then give rating to the community, and of course still give a great impact for it. We now already launched our new roadmap. It's available on the website, and also we have hard copy if you want it. It has been launched 1 year before at Karawang, Indonesia. The roadmap is a new protocol that we will use for 2021 to 2025, which is protocols mean the testing procedures, the procedure, the protocols, the everything that you need to obey to. And this is the new protocols or new calculation sheet for 2025. And as you can see, AOP stands for adult occupant protection, which means the bigger dummy in the car when you crash testing it. And COP means child occupant protection. Safety assist means assistant equipment. Since things like AE and everything is to be calculated under the safety assist. But we have differentiated to motorcycle safety to ensure that there's a lot of technology need to be introduced in our market to save motorcyclists. As you may know, is 2/3 of the total road fatality is from this motorcyclist area, motorcyclists. So that's why we need more. We need to have a safer car that help to prevent us from killing motorcyclists per se. For this 15 days more, we are still crashing or testing using this that you are looking at your now, which is 10% belongs to adult occupant and 25% belong to child occupant, and safety assist 25%. So there is no dedicated regime for motorcyclist safety. So this is the type of calculation that we are doing. As you can see, we have a lot of sector here, from sector 0 to sector 3, because of different economical factor of each country. So it's very hard to come up with a rating, but we are finally success of doing it. And now you can see in our website all the results. Okay, so we have changed, I think this is the 4th time we changed protocol. If you can see the difference between 2011 and 2016 protocols compared to 2017, 2020. So in 2011 and 2016, we only need 1 car to test. because for side impact is just a regulation UNR 95, so we don't need to crash the car. By certificate is okay, and it's quite easy to get fast. And even with that, you have dual rating. So some cars, like some car in Thailand, 0 star, but the car in Malaysia will have 4 star. So it's not good in the means of ASEAN, because it doesn't really help those country who doesn't have regulation like Malaysia. So that's why we changed it to 2017 and 2020. More stringent requirement. We make ESC as almost the highest point, and that's why from that the government of Malaysia has regulated ESC as a standard item in every car since June 2018. So of course, in 20 minutes, I couldn't say much, but this is what has been improved. And next year, we're going to have a better star ratings, and with a motorcyclist, a new regime that could help detection from crashing with motorcycles. This is the amongst the latest results. Of course, there's a few results will coming out in next week. This is our Proton X50, which we crash tested in Malacca, nearby UTM also. And you can see that this report will tell you the injury level of the driver and front passenger, the dynamic test for the child, and how good is the child seat to be installed in the car. On the right, down right graph, you can see pass fail, pass fail. That means that some of the car seat is not suitable for the car. So this is what we are doing, and for to make an assessment. So it's a very long process. And we also discuss with the manufacturer on type of equipment they install in the car. For example, for this X50, Proton plan to sell it in already sold in Malaysia and selling in Thailand per se. Then you can see that people in Thailand will know that they will not have rear passenger seatbelt reminder, even though in Malaysia also. So this is type of equipment that we are telling or educating consumer. When you want to buy a car, then you can choose whatever has been rated by ASEAN NCAPs. Of course, since MCO and everything, we are no longer allowed to travel overseas. Usually we are traveling to Japan, Korea, Australia for testing. So one of the way is that they are sending the vehicle to us, and we just do the installation via video, video conference. And for car that weight 1.4 ton, we test it at Myros PC3. We couldn't test more heavier because of the setup of the lab itself is not for bigger vehicle. It started with plan to just only do research for small vehicle, not for the NCAP. And for this year, we have tested 9 models, and some of the cars is tested in JARI, Japan Automobile Research Institute, especially for the bigger car, and but some also been tested in Myros PC3. Okay, and we have performed 2 models physically performed on this test, and the rest of the model performed by OEMs with final. So because of we are carry over the results, some also will be tested by OEM themselves. Okay, we have released 9 assessment results and successfully received 5-star rating. The ratings the model achieved show that OEM have prepared the development for their respective model to be sold in the region to achieve the scoring of protocols. I believe that you all know that whenever we are testing the car, we make sure that it is the lower standard. Lower standard means if the car only have 2 airbags in Thailand and 6 airbags in Malaysia. So we will only test the car in Thailand, not in Malaysia. So the lowest variant it will be the one that we specify for the crash test. But for the safety assist test like AEB and everything, it depends on the option, no problem. But for the crashing of it, it must be based on the lower standards. So we have also this balloons for AEB system, which costs us around 400,000 ringgit. It's so expensive to ensure that whether the AEB of the car is workable. Okay, sometimes video, but for the I don't think we do have long time, so I might skip this video. And we also have NCAP label, as you know, and most of the car manufacturers already display this label in the showroom or even outside showrooms to ensure that they are showing the real safety of the cars, whether the safety features is there, whether they have ASEAN NCAP or not, or they have other NCAPs. However, we still have not regulated this. Still in the discussion with KPDN HEP, the Ministry of Domestic Trade, and looking forward for 2021 to ensure that we're going to regulate these labelings. So whenever you want to buy a car, you should ask them where's the label, and usually most of the car manufacturers already display that in the showrooms. Okay, we also have a anchor project. Some of you already received grants for anchor projects. So this is what anchor is all about. ASEAN NCAP Holistic Collaborative Research, which is now 29 projects, and it's been between the academician and partners. And most of them is automotive manufacturers and then also suppliers and the crash labs. So we are the middleman who collect all the money and make sure you do the research. So we try to engage both academician and partners in a program called Anchor. So this is the third Anchor, and will be end by I think next year, and end of next year, and then we maybe start Anchor 4 in 2022 perhaps. So for ASEAN NCAPs, we already done so many tests. Crashing is a boring job now because every day, almost every week we have crash tests, but it is very important. We do have 104 models, and variant we have 138 rating. This means that some models have dual ratings, whether it's 4-star and 5-star, perhaps maybe 0 and 4-star. So it depends. You can check in the website. And we do have 28 brands that we tested already. So it's quite high, and most all Japanese brand have been tested. Why is purposely mentioning Japanese here is because 83% of the passenger car market is dominated by Japanese market. Toyota, Honda, Nissan, you name it, Mitsubishi. So they conquer Asia. They conquer ASEAN. And if we calculated Perodua as Japanese brand, if you want to, then it become bigger, of course. But of course, that is how we do calculate now. So we tested top 20 except Mercedes and Hino, and we tested BMW. And how many roadmaps have been developed? It's now three roadmaps, and we'll start next year for 2026. And we are now making our own dummy, is a motorcycle dummy. And the project is now in France, and perhaps we have our own dummy in 2026. So for Safer Cars 2020, we would like to say here that we are not looking into pedestrian because only around 10% of the pedestrians. What is the problem of ASEAN? The ASEAN is 70%. Problem is from motorcyclists. So we do everything except for pedestrian protection. Is different from what Japan have per se. Japan road fatalities half is from pedestrians. That's why they are making car that is safe for pedestrian. So we have 60%, 70% road fatality of motorcyclists. We have to make a safer car for motorcycles. It's very easy calculation. Okay. And next year, finally, not finally, I mean, we are looking forward to have our own 10th year anniversary, which will happen on 8 December 2021. So we are going to make this as big as possible. Our biggest event is in 2019, where we have invited Deputy Prime Minister at that time to officiate our 6 days event, and total number is 1,600. We are targeting 3,000 people for this event in December next year. This is our website. So please, YouTube, we have Perodua Myvi. We have, I think this is not the biggest one. The biggest one is Mitsubishi, the new Mitsubishi, I forgot the name. It's 400 overviews, 400K views. So please enjoy the YouTube channel for car crash and others testing like blind spot also. So we have our own channel, and we also have Google Play. We also in the Apple apps, so you can also download and try to compare the results. Yeah, Mitsubishi Expander. Thank you. And the result before you buying any cars, make sure that you have a safest car. As the I mean, the effectiveness of ASEAN NCAP, I believe even Pro2 Asia now have advanced safety. Even Pro2 Asia, the cheapest or the most affordable car in Malaysia now have an equipment of advanced safety like AEB. And so it is much more, what I can say, stabilized program. To find a safer car in Malaysia per se, as a Malaysian consumer, it's much difficult for you to find a non-safer car rather than find a safe cars. Everyone want to say that they are making safest car. So with that, I think I will end my presentation. I will give more time for you to ask me, if any. Then thank you.
Dr. Khairul, I would like to express our appreciation of your most interesting talk. So now we'll have again a question and answer session.
May I ask a question, Dr. Amrik?
Yeah, sure. You can proceed.
Okay, thank you, Dr. Khairul, for very interesting sharing sessions. I would like to ask about the autonomous vehicle or automated vehicle. You talk about safer vehicles and so on, and I think automation is one of the way to enhance safety on the road. So what is the Asian NCAP stance or view on the automated vehicle technology?
Okay, thank you. The most difficult question for the first place. The problem of crash per se, or the road safety, is human, definitely. Some researchers say 80%, some researchers say 90%. Whatever it is definitely more than 80%. So that's where, when we have an autonomous car, that will solve the problem, because you don't any longer depends on humans. So that's a concept that everyone happy to agree with. But there is two type of groups. One group is autonomous group, who's really looking into making this as soon as possible. But there's also a group saying that let's do it step by step. So NCAP per se, we cannot do it as the first group. We need to do it step by step. So our first step in NCAP is to make sure, as for ASEAN, some countries doesn't have a regulation. R94 per se, frontal regulation, side regulation. So when we start last 9 years, we emphasize on having a good protection of cars, having an airbag per se, passive safety is the most important part. But we also the next step is to ensure that next car will have stability control, ESC. So that is why our protocol, our roadmaps aligning towards that. So the 2021, 2025 roadmaps is much focusing on motorcyclist safety equipment, which is blind spots and the advanced lighting. So we want to make sure that every manufacturer, whenever they're producing cars, they are producing cars that could help us from crashing with motorcycles. So it will be. But for us, we are the second group who's really working step by step to ensure that
Right.
the
Okay.
economical factor, or you can still buy the car. Otherwise, if the car is too much a high price, then everyone will not benefiting from any of it. So I hope that can explains how we think and how the thing is. Thank you.
Thank you, Dr.
Thank
Khairil.
you. Okay, thank you, Dr. Jeffrizal, for your question. We have the next question in the chat box. I'll post it to Dr. Khairil. So the question is by Ahmad al-Nabil. So basically, he would like to know how the selection of the cars are done for testing. Are the cars randomly selected or provided maybe by the automotive manufacturers?
Okay, there is two type of selection. One is where we are using our own money to buy the car. So we just go to the showrooms, and that is much easy in the early days because still there's a car without airbags. But now it's become difficult because we have to buy it from Indonesia or Thailand. So this is where we ask people to buy and bring it to the lab and crash it. But we also have, I think 90% now is a sponsor vehicle. It's sponsored from the car manufacturer because they have developed a 5-star cars and they want to tell people how this 5-star car is. So the method of that is by giving us 20 VIN number, 20 vehicle identification number, and we will select and they will send it to us. So that is where how the selection is. But whatever whatever we select from them, it must be the lowest safety specifications. As I mentioned just now in the presentation, lowest safety means for lowest safety for when we test the passive safety, meaning how many airbags per se. If it's standard 6 airbags, then it's okay to test anywhere, from anywhere. But sometimes maybe the car from Myanmar only have 2 airbags, then the manufacturer need to send the car from Myanmar. We will never test the things from Malaysia or Thailand per se. So it has to be the lowest safety car and with 20 VIN number for selection.
Okay, we have another question. Basically, the question is like this. While airbags are considered as a compulsory safety feature, but other technologies, active technologies such as ABS, ESC, and traction control, it's not made compulsory.
Okay.
Compulsory safety feature,
I think maybe the student is not really understand the whole situation now. NCAP is not regulation. So NCAP is a consumer approach assessment. This is between safe and safer. Okay, the definition between safe is much more whatever road transport department has been approved. So any cars come to Malaysia per se, I'm talking in the Malaysia context now. Whatever car you want to register here, you have to pass the vehicle type approval. So vehicle type approval have a lesser requirement compared to NCAP. NCAP is to ensure that car manufacturer is producing a safer car. So in VTA per se, now you need to install electronic stability control. There's a must. So AEB not yet, but for NCAP, if you have AEB, you have more points. So it is totally different things, different concepts. So we not everyone has to be tested by NCAP. However, the biggest success that we did is we test BMW. We bought the BMW and we test and only score 4-star. So I'm telling the story to everyone and making BMW manufacturer very angry with me. Because whatever they do, they are not doing it for us. They are doing it for the European version, for Japan version maybe. So the car is not suitable in ASEAN. It's only 4-star. It couldn't score 5. So I think again we need to understand more between the regulation and consumer approach. So regulation is whatever has been approved by JPJ, Road Transport Department. The NCAP is what Myros is doing for giving ratings.
Okay, Dr. Khairul, maybe a last quick question. What is the common simulation software that is used for crash tests, if there is in Myros?
We don't have really simulation software for crash testing for our assessment. We only do physical test.
Okay, thank you very much for your answer, Dr. Khairul. So now I think that's all for the question and answer session. We are coming to the end. In this session, 2 presentations were delivered by our invited speakers. The first one was on tribology by Professor Umehara, and the second one on vehicle safety by Dr. Khairul. So we hope that the participants have greatly benefited from these talks. Now I'd like to request all the participants to switch on their cameras so we can have a photo session. I'd like to request all participants to switch on your cameras so that we can have a photo session, a group photo session. So Dr. Jufrizal will snapshot the photos here.
Okay, Sechis. Okay, let me take a picture of the second page. Right. So smile. Right. Okay, and then so we have around 260 participants. So there are few pages here. Right. Okay. All right. Okay, thank you.
Okay, thank you, Dr. Jeffrey Zong. I would like to thank again our speakers for their very interesting and stimulating contributions and the participants for joining this session. All participants are invited to the MERT 20 closing ceremony and award presentation at 2:30 in the afternoon. Again, thank you very much and see you in the evening. Bye.
Thank you, sir.